In order to evaluate each of these limits, we're going to be using the substitution method. Substitution is one of the easiest ways to calculate a limit because all you really need to do is plug in these x values that you're approaching into the x's of the function. So in each of these cases, all you really need to do is plug in 1 wherever you see an x, which for this first example would lead to the natural log of 1 divided by 1. And in the second example, it would lead to a 1 divided by natural log of 1. Now, in order to actually calculate these answers, we need to know a little bit more than just calculus. In this situation, we need to figure out what is the natural log of 1. Now, if that's not something you have memorized, here's one way that you can consider thinking about that problem. First of all, please realize that the function natural log of x has an inverse function that is a little bit easier for us to figure out. That would be the function e to the x. So if these functions are in fact inverses of each other, well, maybe we can use that to figure out what the natural log of 1 is. So in this case, if I asked you to calculate the natural log of 1, what is that really asking for? Well, that's asking you to figure out what is e have to be raised to in order to equal the value of 1. When you get asked to find the natural log of 1, this is really what you're being asked for. What is that exponent that you have to raise e to in order to get a 1 as a result? In this case, I hope it is fairly obvious. We have to raise e to the 0 power. That means the natural log of 1 equals 0. Now, this takes some time for people to fully understand because natural log is not a function we've used every single day of our lives. So if I asked you, calculate the natural log of e. Well, many people know that these cancel out, but it doesn't give you a 0. In order to understand its answer, again, consider this question. What does e have to be raised to in order to equal e? Again, that's what the natural log of e is really asking. What power do you have to raise e to in order to get a result of e? Now again, this one should be pretty obvious for us. That answer would have to be a 1. So what is the natural log of e? It's 1. Now, when you look at these two facts or these 2 points that we've just figured out, it actually gives us some very important knowledge about these 2 functions. Here's what the natural log of x function looks like, and here's what the function e to the x looks like. Here's y equals e to the x, and here's y equals natural log of x. We all know that this point here on e to the x is 0, 1. If you plug in 0 into e to the x, we get an answer of 1. Now let me ask that question again. What is the natural log of 1? It's 0. That x-intercept on the natural log function is the point 1, 0. So the natural log of 1 is a valuable piece of information because it helps us with our x-intercept, and we can calculate the value natural log of 1. In addition, if I ask you to plug in 1 into the function for e to the x, you get this point here at a height of e. So what does that mean about the natural log of e? Well, if I were to pick this location and calculate that point, if I asked you what are the coordinates of that point, that would be e, 1. Now, back to the original problem at hand. What was the natural log of 1? By this point, I hope now everyone knows this answer is really 0 over 1, and the second problem is really 1 over 0. In calculus terms, 0 divided by 1 means the answer for our limit is 0. However, whenever you have a non-zero number divided by a 0 from substitution, this means that the function has a vertical asymptote at x equals 1. So in this situation, our limit is best said as does not exist. If you want some extra practice using limits via substitution, try out these 3 problems. Post your answers in the comments below, and if you're my calculus students, try these problems out. It'll help you on your makeup quiz. Good luck!